Okay, so what is a coterminal angle? It's an angle that lands in the same position as another angle. So for instance, on a clock, let's pretend the time was 9:05. The minute hand position would also be in the same position at 10:05 on a clock, right? Or 11:05, or you can backtrack and you can go to 8:05, and that minute hand would have been in the same spot. Okay, so that's what's going on. So if I want to draw 30 degrees, it would look something like that, right? That's a 30-degree angle. So can you think of another angle with a different number, but would land, that arm, the arrow thing that I drew, would be in the exact same spot? 390, yeah. So if you swivel one whole circle and then that much, 390 degrees is in the exact same position. So that's coterminal. That's what it means. Okay, so Kenyon, what did you actually do as a number sense there? What did you do to get that 390 number? Did a whole rotation. So you were doing that in your brain, right? Adding 360. Okay, now, you know what else I could do? I could spin. I could do it like that. I could do 2 spins and then land there. Okay, what would that number be? That would be 750 degrees, right? What else do you think you could do? I could spin the other way. So if I started and spinning backwards and landed there, does anybody know what the number would be for that angle? Negative 330. Okay, so what was I doing essentially? I was adding 360. Here I added 2 360s. Here I subtracted 360. Okay, so now let's talk about the same idea in radians. So 3 pi over 4 would be right there, 3/4 of the way to a full pi, right? A full pi is the half circle, remember? Okay, so we would understand, what if we did an entire spin plus that? That would be a coterminal, right? Which would be a different number. Okay, so we're going to take that idea that we did last time. So really, this is what we did last time, right? We added 360. But I can't talk in radians and degrees in the same sentence. So can we not do 360 and change that to a radian? What is that in radians? 2 pi. Okay, so here's the thing. When we add with fractions, I can't add together unless I have what? Something with the same bottom. So how much is 2 as a fraction with a 4 on the bottom? So what divided by 4? 8. So that's, I'm doing the exact same thing. I'm adding a full circle. I'm adding 360, but now we got to make everything in radians, and then we also got to think about fractions. So this would be the number 11 pi over 4. Can you do this backtracking. Can you show me what that would be? So start at 3 pi over 4. And can you now do a backwards rotation instead? That makes sense where we're landing? Negative 5 pi over 4 would be that position. Okay, so find all the coterminal angles for this, and this says I have to be in a certain domain, okay? Okay, so I'm going to be trying to go up or down 2 pi. That's my goal here. I'm going to go up or down 2 pi. For this one, because my bottom is 4, then I'm going to do 8 pi over 4. So what does this thing mean at the end? It says a domain. It means my numbers can only be as high as this or as low as this, and you can't go past. Okay, so I'm also going to write all this stuff with a fraction over 4. So what would we do? Something over 4 is 4. 16 over 4 is 4, right? So we have to make a note that this is as high as we can go, right? And this is as low as we can go. We can't go outside of that after. Okay, so here's what I'm going to do. I'm going to start going up or down. I don't know how far I'm going to go, but if I go up by 8 pi over 4, I would hit 17 over 4, right? If I went up by 8, I'd get to 25 over 4, right? But you know what? These are too high. I can't be above that number. Okay, so let's go down by 8. So if I went down by 8, this would be a 1 pi over 4. If I went down by 8, so now I'd be at negative 7. If I went down by 8, it'd be at negative 15. If I went down 8, uh-oh, that is, I've gone too far now on that one, right? Okay, so which ones did I do that worked? This one is good. It's inside that. This one is good. And this one is good. So there's my 3 answers. Okay. This one is not an answer because it was just the original question. So I wanted a different angle than it. Okay, so let's do this one. It's the exact same thing. Okay, so we're going to be going above or below by a circle. So a 2 pi. What would that fraction look like? Because this time we're using 8 on the bottom. So I'm going to go increments of 16 over 8. Would that make sense? 2. 16 over 8 is 2. lowest you can get to? Negative 16 pi over 8 is the lowest. And what's the highest? 32, is that what you said? Over 8? 32 over 8, because that's a 4. Okay, so here we go. If I start at 15 pi over 8, okay, I'm going to go up by 16. So now I'm at 31. That is good, right? I'm good. Would we agree that if I went above any more, I'm going to be too high on the next one? Would you already see that? So I'm going to stop because I can see the next one is going to for sure be past 32. Okay, so from 15, can you go down by a 16? If I went down by 16, I get to negative 17, which is too low. So no, so you can't do that one. You've gone too far. So stop. That's it. You have 2 answers on that one. Okay. So here's one more thing we're going to learn. So this is the general form for coterminals. 266 degrees plus 360k, where k is the element of integer numbers. What in the world is that? Okay, so what is an integer number? Negatives, 0, and positive numbers. So that's why I'm saying I can do any integer amount of 360 with this. Does that make sense? I could go back 1 360. I could go back 3 360s. I could go ahead by 5 360s. But it has to be an integer number. You can't pick any number because you can't pick 2.3 circles. That doesn't get you to the same spot, right? You have to do a full amount of circles, either forward or backwards. Okay, so then how do you do this exact same thing, but in radians? Plus 2 pi k. K is an integer number. Okay, here's a note on the exam. All of a sudden I saw this letter Z. Apparently they used the British symbol Z for an integer. So just a side note, probably all year we'll use I's, and I'll remind you on your exam again, but they used the British version of integer, which was, I don't know why, but a Z.